Okay guys, so this is a fairly quick video on the reactions of acyl chlorides, and what I'm going to do here is start off by going through the mechanism for how acyl chlorides react in all the reactions we're going to do. Now, just to make it really clear, this is not a mechanism that is directly on the syllabus, so it is not one I would spend ages memorising. This is here just to help your understanding and also out of interest. And in general, it is good to understand how Cagliaros work. So here's an acyl chloride. Now, acyl chlorides tend to react with nucleophiles. So just take a second to ask yourself, maybe you could pause this video and try and think in your head, what is a nucleophile? Okay, so a nucleophile is a lone pair donator. It donates lone pairs of electrons. And the nucleophile, and we'll look at some specific examples in a second, the nucleophile that the acyl chloride will be reacting with will be bonded to at least one hydrogen. Now, what we can do is we can break this down and say the nucleophile is going to release that H as a H+, and we'll be left with our negative nucleophile. This can then attack the delta positive carbon. There's going to be a dipole here because of the difference in electronegativity. And so this will break that bond there. That will leave us with this. So the nucleophile will now be attached, and we've got our chlorine, but we've also got a dipole between the carbon and the chlorine, so a lone pair from the oxygen can then go back to remake that second bond, and then the carbon to chlorine bond breaks off, and what do we end up with? You've added, sorry, that's a carbon there, you've added on the nucleophile, and then the chlorine has been released as a chloride. It's now got that negative charge. And then the hydrogen that we had earlier combined with the chlorine to make HCl. So you'll find with acyl chloride reactions, you always, initially at least, get a HCl side product. And that's because the hydrogen has broken off the nucleophile. The rest of the nucleophile can then be added on. Essentially, it's replacing the chlorine. So let's have a look at how this works in action, and then we can also come up with a quicker way of remembering this, because like I say, this is not directly on the syllabus. So the way I think of it is like this. Whenever your acyl chloride reacts, ultimately the chlorine is going to break off the acyl chloride, and the hydrogen is going to break off the other thing, the nucleophile, and they're going to join together to make HCl. So let's do that. So I have broken off the chlorine from the acyl chloride. I have broken off one of the hydrogens from the other thing. So H2O, lose the H, you're left with OH. Carbon and oxygen can then bond. And again, this isn't the actual mechanism, this is just a quick way of figuring out what your products are. And then you get HCl side product. Let's do it again. So break off the Cl from the acyl chloride. Break off the H from the other thing, whatever that other thing is. Those two things can then join together because they've each got a spare bond. HCl side product. Again here, so break off the Cl from the acyl chloride, break off one of the H's from the other thing, and that's going to make HCl. I'm not going to quite, I will write it in. I'm going to do it lightly. The carbon and the nitrogen can then bond. There's an extra thing that happens in this case as well, because we've made HCl, hydrochloric acid. Now, believe it or not, hydrochloric acid is an acid. But ask yourself, what kind of thing is ammonia? This nitrogen has a lone pair. So what will it be? It'll be a base, won't it? So acids and bases react together. So initially, when you react an acyl chloride with ammonia, it'll react and you'll get the HCl. But as HCl is an acid, a second molecule of ammonia then reacts with the acid. That's why I did it lightly. And so you'll end up with NH4Cl, basically NH3 and HCl joined together. So you end up with an ammonium salt, in this case ammonium chloride. Okay, and then finally we've got our acyl chloride and an amine, exactly the same thing. So break off the Cl, break off one of the H's from the nitrogen, and then join them up, and that's going to make a HCl. But again, an amine is a base because that nitrogen's still got a lone pair. And so the HCl that you formed will react with another one of them, and you'll get, again, an ammonium salt, methyl ammonium chloride. So a short, quick hand way of doing these reactions, although it's not the actual mechanism, is to just break off the Cl, break off a H, make HCl, and then join the rest of the stuff together. Be really careful if your reagent is a base, because obviously HCl is an acid and it will react with that base via a second molecule of the base. There we go.